Okay, so let's take a look at the first part here, definition. A scalar, we call a scalar is a quantity that has only magnitude. Okay, as you see the example here, and vector is a quantity that has both magnitude and direction. Meaning, direction here is we could tell us where is the the vector moving on to the left, right, or any from one point to another point. Okay, so as you see here is this example here: velocity, force, weight, and momentum. So geometrically, vectors can be represented by a directed line segment. As you see here now, that we have the beginning, the starting point from A to one point of destination here, from tail, the initial point, to the head of terminal point. So from A, look at direction ahead of the, we call direction here. So we can put this as a direction, we call the vectors of A, B. Okay. Okay, a vector can be written as a vector of A, B, or we can represent with a single vectors notation of U here with a curly sign from A to B, or we call with this we call a label here. So magnitude, also called norm, denoted as a vectors of A, B, or we call make the magnitude as we call a U here. For this one, we call this as so we call the sign of absolute values of the, we call vectors of A, B, or absolute values of what we call the vectors of U here is the length of the line of AB. And direction, the arrowhead on the line of AB, as you see here, from A to B. This shows the direction from A to B here. Okay, type of vectors, zero vector, null. A vector which has a zero magnitude represented by vectors of O, we curly sign of this, and vectors of A. Unit vector, a vector which has a magnitude of 1, denoted as a unit vector of A, equal to vectors of A divided by absolute values, or the distance of the vectors of A here. And position vector, any vector that starts from the origin of 0. OA is known as the position vector of the point A relative to 0. Means that if this, for example, 3 dimension of vectors here, X, Y, and Z, so this is the origin point of 0, 0, 0 to any point of A here. Okay, so from 0, 0, 0 to the point of A, so OA is the position vector. Okay, OA is a position vector. A free vector which is not has a fixed position. Okay, equal vectors. Look at this one here now. Two vectors A and B are equal if both have the same magnitude and the same direction. So we need to consider two things here. First, the magnitude and the direction. Okay, P and Q, look at that, we call from point of 1 to another point here. It looks, we call the same, and also the direction direction are also equal here. But then for P, R, and S, P and R, you can see that direction to one here and one to another, a different direction. P and S might be same magnitude, but then they have a different direction. Okay, 1, 2. Okay, you see this we call direction here, and one opposite direction of the P. Opposite. So P, R, and S are not equal at all. Okay, negative vectors of A has the same magnitude as A, but then oppositely directed. Okay, so you can see here now, A and A has the same magnitude, but then the direction is opposite. We call different, oppositely directed. Okay. And operation of vectors, addition. So then the vectors of A and the vectors of B, if we combine here now, it gives us a vectors of A plus B equal to a vectors of AB. Okay, using the triangle law. Okay, now, why do we have two different vectors here? A plus B, then we are referring to this, the vectors from the point here and the vectors of A plus a vector of B, okay, to achieve at this point, okay, at this coordinate. But then, look at this one here now, from this point, then you come, first we using the root of vectors of B and then plus with the vectors of A. So that's why they come up with a different we call addition of two vectors, even though it gives us the same direction, the same destination last point here, but then because we're using a different root, then it gives us a different addition of vectors. Okay, using the parallelogram, notice that A plus B equal to B plus A. If A is not 0, the multiplication of a vectors by scalar k is denoted by Ka. Okay, so this one single vectors of A. So look at this one here now. The magnitude of these vectors is double from the vectors of the origin of A. So it's double or 2 times the vectors of A, and then this is also double the magnitude of these vectors, but then look at the direction here now. Okay, the direction is oppositely directed or different, and here now this we call the green line here is half of the vectors of A. If this magnitude is 4, then this is 2, half of the magnitude of the A. So the distance of this is half of the distance of this. Okay, so here now, if k greater than 0, then k multiplied with A is parallel to the we call with the vectors of A, and Ka has as we call the absolute values of Ka equal to k with the vectors of A here, distance. K multiplied with the vectors of A has the same direction of the vectors of A itself. Okay. Okay, I'm not going to explain all one by one, which I think that there's nothing much we're going to discuss this. It's very directed. Now, when given to us the vectors in 3 dimensions, look at the definition here. This is the point of origin 0, 0, 0. Okay, with a vector with coordinate of 0, 0, and 0. So then, from O to this point of A, we denote as we call a vectors of A here. Okay, look at this one here now. O to A, from O to A equal to OP, from O to P here. from O to P plus with P to Q and Q to A. Okay, even though it took such a long distance, okay, to reach this point of A, but then because in vectors we need to consider two things. The first is the magnitude and direction. So even though we take the three different routes from O to P, P to Q, and Q to A, but because we reach at the same point of destination here, so we simplify this as an equal to the vectors of OA. Okay. So from any vectors of A and B, and for any scalar of K, then the addition and subtraction of vectors of A plus with a vector of B. So we adding the magnitude of the same direction of I with an I, then we get A1 plus B1 for I, then A2 with B2, addition of the magnitude of A and B for J, and also A3 with B3 for K. Then subtraction of two vectors, opposite of this, with we only operate between the magnitude of the I with an I, J with a J, and K with K. Okay, as you see on the screen here now. Multiplication of vector by a scalar. So vectors of A we multiply with a K, and also let's say if I given here the vectors of A equal to 3i minus 2j plus k, so then 2 times A means that is 2 multiplied with 3i minus 2j plus k. So 2 times 3 equal to 6i, 2 times negative 2 equal to minus 4j, 2 times 1 equal to 2k. Okay, that's example here. And the magnitude of a vector here, absolute values with the distance of this, a square plus ba2 square plus a3 square.